Okay, so we're back to another competitive exam here. And again, if I were looking at this problem set, I would have to make a determination, what's the lowest hanging piece of fruit I could grab? So, kind of looking at it, I'm going to say 1 sort of looks like it's low hanging. Let me make sure it's 1. 2 doesn't look bad. 3 is a trig thing. I don't know, it doesn't look that bad, but it might be tough. Complex numbers, people have a tough time with complex numbers, and 5. So I'm going to say, I don't know. I mean, they look about equal. Looking at it, you know what? I think I'm going to try to do number 1 first. I'm sorry, number 2, because it looks so familiar to me. It says, given 2 polynomial functions, right, I see the polynomial function are given to me. It says, find all values of a for which the 2 polynomial functions have at least one common 0. So I think this is perhaps the lowest piece of fruit I could grab. I can write down f of x. I'm going to factor it. It looks factorable to me. X and x. Let's hope. 2a and 2a. And it looks like plus plus, right? Let's not make it wishful thinking. Let's make it truthful thinking. X times x is x squared. You get 2ax plus 1ax is 3x. Looks great. So what are the roots of this equation over here? The roots would be x equals minus 2a. And the other root would be x equals minus a. All right, so given the 2 polynomial functions, find all values of a for which the 2 polynomial functions have at least one common 0. Let's take a look at least one. Let's say they have this in common. What would I do? I'd plug it in. Or I'd plug into the second one. So what's g at minus a? All right, I don't know. Let's see what happens. That would be a squared minus a plus a would equal a squared. And if that's a root, that would have to equal 0. So I'm going to say, when would a equal 0? When would a squared equal 0? Only if a is 0. All right, let's do the other one. Let's do g of minus 2a. Let's see what happens over there. What would you give there? I'm doing g. It's going to be 4a squared. Let's see, x is minus 2a, right? So minus 2a plus a. And let's see what that gives me. That gives me 4a squared minus a. Let me factor that. That's a, and that would be 4a minus 1. Well, I'm getting 0 again. That's good news. And what's the other one going to be? A is a quarter. Again, what was your question? Find all values of a. I did find all values of a. A is 0, and a would be 1/4. All right, let's go to the answer key, see how we did. This is number 2, right? So let's see. Well, they did something different, didn't they? But they got this part. I see that. Then they used quadratic formula. All right, that's fine. Let's see what they got for an answer, though. Yeah, they got it. 1/4 a. They go on to say a much simpler approach. The approach I just took is the one I just gave you. It's still going to lead to the same conclusion, that a is 0 or 1/4. All right, so I'm going to say relatively simple. All right, that was a good piece of low-hanging fruit to grab at. And I want to go on. All right, so I'm going to look at another one. I'm kind of looking around. I don't know. I'm going to try number 1. So trying number 1, what do they want to know? Find the remainder upon dividing. So one thing you could do is you could do x minus 1, and you could divide that into x plus x cubed plus x9 plus x27 plus x81 plus x243. And you could go through the division process until you find a remainder. If I can be honest with you, I don't know if I want to do that. It looks like a tough division for me. I'm not saying it's impossible. I'm just saying I don't think I want to do that. Let me get my eraser out. I'm done with 2. Again, these are videos. You can always pause the tape and copy things down if you want. But I'm going to get my nice clean piece of paper now. And I'm going to start looking at number 1 as being maybe something a little bit different. And what I'm going to do is I'm going to say, let me write this down. X plus x cubed plus x9 plus x27 plus x81 plus x243. I forgot to erase this piece over here. Divide by x minus 1. Well, I would get a quotient. I'll call it q of x. I don't know what that is. And I'm not really interested in what that is, by the way. Plus a remainder. I'm going to multiply both sides by x minus 1. This is the remainder theorem, by the way. You get x plus x cubed plus x9 plus x27 plus x81 plus x243 would equal q of x. Oh, I'm sorry. I forgot to, I didn't divide the remainder by the divisor. And the remainder is something I didn't finish dividing by. I didn't finish dividing by x minus 1. Sorry about that. Times x minus 1 plus the remainder x. That's if I multiply both sides by x minus 1, by the way. So what am I going to do now? I'm going to plug in 1. And so this is why plugging in 1. The number one reason I'm plugging in 1 is I'm not interested in this part over here. And if I plug in 1, that part just disappears. So I'm going to plug in 1. So I'm going to let x equal 1. And what do you get? 1, 2, 3, 4, 5, 6. That was easy. What's this thing going to be? Well, I don't know what q is, but I know x minus 1 is 0, so that's 0. And then you can get r evaluated at 1. Well, r evaluated at 1, right? What's that going to give you? That's going to give you 6. A remainder is 6 now. This is the remainder. All right? That's the remainder. The remainder is 6. So I'm going to say low-hanging fruit. What's the remainder after I do the division? The number would be 6. Let's look at our key, see what they said. And I think they talked about the remainder theorem. They did. That's right over here. And they kind of wrote down what I wrote over there before. And let's see if they said it. Yeah, 6. I see it. All right, so I'm going to say that one's done. You got some low-hanging fruit done already. I thought 2 was the easiest one. I thought number 1 wasn't so bad. You kind of went through that quickly. And your confidence should be shooting up. Now, I think one of the worst things I've ever experienced in life is if I can't answer any questions. And that's when things get really scary for me. I mean, they're extremely scary when you can't answer anything. You start to question if you can answer anything. And you say, I can't get anything right. I'm looking at these things over here in complex number. They look kind of scary. Trig scaring me. I think I can do number 5, though. All right? And what's 5 says show the range. Now, you understand what the range is. The range is f of x. And they're telling me that I should be able to show that the range of this problem is between 3 and 1/3. All right? And I'm going to simplify that a bit. I'm going to say 1, 3 times f of x, and 9. All right? And then I'm going to pop the f of x, and I have an inequality to solve now. And I'm trying to figure out if I can solve that inequality. And what would you get? 1. And then I got to do 3 times f of x. And that's going to be 3x squared minus 3x plus 3 over x squared plus x plus 1 less than or equal to 9. Now, before I proceed forward, I want to get rid of the fraction, but I have to do something first. I have to make sure that x squared plus x plus 1 is always bigger than 0. Well, let's go through that. I'm going to look for its roots. And it's going to be minus, let's see, minus b, which is minus 1, plus or minus. What do you get there? B squared, which would be 1, minus 4 over 2. What I notice, the roots are complex. That means there are no real zeros. So I'm just going to take one test value, see if it's above or below the x-axis. Well, what's a good test value to choose? I'd say 1 or 0. It's always positive. So I know that this thing is always positive now. I know this is true. So I'm going to multiply each side by x squared plus 1. What do you get? X squared plus x plus 1. And then I get 3x squared minus 3x plus 3. And then what do you get? You get 9x squared plus 9x plus 9. Well, you know what? I got a double inequality, and I'm going to split into 2 parts, by the way. So x squared plus x plus 1, and you get 3x squared minus 3x plus 3, and I had to solve them separately, by the way, because it's too complicated to solve them at one time. 3x squared minus 3x plus 3 less than or equal to 9x squared plus 9x plus 9. Well, let's see if I can do this. I'll just make this side 0. You get x squared. I'm sorry, you don't get x squared. You get 2x squared, don't you? 2x squared. Let's see, minus 4x plus 2. I'm going to divide both sides by 2. And you get x squared minus 2x plus 1. And then I'm going to put this over here. This looks like a perfect square. X minus 1 squared. Now I'm kind of looking at that, and I'm looking at that, and that's true for all real numbers. So this is true for all real numbers. The whole number line, that's satisfied. Let's look at the other one. And when you get over there, well, let's write this down. You would get 6x squared plus 12x plus 6, 0. I'm going to divide by 6. And what do you get there? X squared plus 2x plus 1. What do you get over here? You get a perfect square again. So it's x plus 1 quantity squared. And this is true for all real numbers. So what have I shown? I've shown that this is true for all real numbers. So yeah, we verified that this is the range of the problem. Let's look at the key though. This is number 5. I'll go back to that. Let me get my eraser out to get rid of the stuff here I don't need anymore. We did this one here. We did number 2. Number 2, they got some work down there for you. Some work is more elegant than the others. But again, you decide what your work is. Don't let other people tell you what your work is. You do your own work. I didn't do 3. I didn't do 4. But we're working on number 5. And let's see what they did. I mean, they basically did the same thing. I want to point out they got this down, they got this down. A little different, I divided by 2, but they have this down. And a little different, I divided by 6, they have this down. Hey, basically, we've shown what we need to show. We did a good job of that. All right? Now, granted, I want to point out they also provide a graph for me. And I want to point out the reason for showing a graph over here is to kind of look at it. It tops out at 3, and it bottoms out at 1/3. All right? Tops out at 3 and bottoms out at 1/3. Do you need to do a graph? No, they didn't ask for that. Why do I put graphs down? Well, I'm hoping that students do look at what we write down and try to make sense of what happens over here. All right? So yeah, they put more information down there, but probably too much information at this point. So I got to go back and let me just erase this business over here. And let me just erase this. I'm done with this. And I got, just going back to the original set. Let me point out what I mean by that. We did a lot already, right? So, we did 1. We did 2. I skipped 3. I skipped 4. And I went to 5. And we did 5. I'm going to erase this now. We're done with this. And again, these are videos. You're more than welcome to stop the tape. Sorry about that. You're more than welcome to stop the tape and copy what we have written down. Again, this is my chicken scratch. On exams, this basically is chicken scratch. All right? You have to type things up and make them more presentable, by the way. So I'm going to do 4 instead. And so it's to describe geometrically all the points in the complex plane. I want to just remind you what a complex plane looks like. Complex plane looks like this over here, where this is the real part, and this is the imaginary part. And there's points over here, and those points over here are going to be in the form A plus BI, with the understanding this is the A coordinate, and this is the B coordinate over here. All right? So what I'm going to do is I'm going to kind of write this down to make sure you understand what it means. And I'm going to say Z is a complex number, and the complex number is going to be A plus BI. So I need to know what the absolute value of Z means. The absolute value of Z means, well, it's what's called the modulus, and I got to write that down for you, and that's going to be the square root. It's basically just a distance problem. A squared plus B squared. All right, it's the modulus. So let's take a look, see if we can figure it out. And again, I'm geometric, I'm wondering what that looks like. So the absolute value of 1 is 1. And the absolute value of Z is the modulus, which is the root of A squared plus B squared. And this says it's less than 2. Geez, I guess I got to solve that. Well, one thing I do know, Z can't be 0, so this point needs to be removed, because I'd have a division by 0, right? So let's write this down. So I'm going to put down 1/2. The modulus is a non-zero number now. It's positive. And this would be this over here. And what is it going to be? 1/4. And you get A squared plus B squared. Well, I think I know what that looks like, and I'll tell you what it looks like. It looks like a circle centered at the origin. Right? And this is the real part, and this is the imaginary part. This is a circle of radius 1/4. All right, this equation of a circle, right? And what do I know? Well, I got to shade it in for you, and I'll kind of do that in blue. So it's everything outside the circle. I don't have to worry about the non-zero number now. It's everything outside that circle. All right, let's look at the K and see how we did with that one. See if we did that. This is number 4. Let's see what the work looks like. Yeah, I think I did this part over here. Let me just check this for you. I think they visualized it. Oh, you know what? I made a mistake. I just realized it. And some said, how'd you know I made a mistake? I looked at the key. It's not 1/4. What's the radius over there? This is r squared. So what's r? R is 1/2. I'm sorry about that. I made a mistake over here. And you got to be more careful about that, right? Now, granted, on the competitive exam, they'd catch that, but at least you got, you got a lot of work down there. And hopefully I'm not totally forgive you, but give you cut you some slack on that one. So circular radius 1/2. It's every point outside that circle. You also got it in dashed because it can't include the edge of the circle. Let's go back over there. And again, it's important I start to realize that I make mistakes, and I want to rectify my mistakes. So over here, circles, 1/2 centered at the origin, and then get the graph. Let's take a look at the graph. This looks like a nice looking graph, much nicer than mine, right? Okay, let's go back, and I'm going to do the other one. The other one's much more difficult. And again, I probably need to get some erasures going over here. I'm sorry, I'm going way too far back, aren't I? I don't know what I just did there. All right, let me start to erase. And I got to visualize this guy now. Again, some people are better at this than others, but I'm still going to let Z equal A plus BI. And what do I got? Let's write this down. You're going to get the absolute value let's see, a plus bi minus 1. And what do you get on the bottom? Well, let's see. You get a plus bi plus 1. And they want it to be less than 2. And I got to visualize this thing. And this looks like it might be tough to visualize, but I do need to get it in the form of a plus bi. And that's going to be tough, but I'll see if I can do it. And I'll write this down for you, and I'll put it aside for you. I'll tell you what I'm doing over here. I'm just working on this part now, because it's a little complicated to me. And I'm going to write this down, a plus bi minus 1, a plus bi plus 1. And let's just play around with it a little bit. So I'm going to put down, let's see, maybe I'll rewrite these a little differently. Let me erase this. I'll put the real part down, so it's a minus 1 plus bi. And at bottom you're getting a plus 1, right, plus bi. I'm going to multiply the top and the bottom. Let's see if I did that right, a minus 1, yeah. So it's going to be a plus 1. Don't be alarmed when I do this. Minus bi. And this is going to be a plus 1 minus bi. Again, this could be a dead end, but I'm trying to get this to work out nicely. And what do you get on bottom? You would get a plus 1 squared minus b squared I squared. All right? Now the top's a little more difficult to do, and you're going to get a squared minus 1 minus b squared I squared, and then you're going to get minus, well, it's going to be more difficult for me, and it'll complicated, but I'll see if I can do it. So minus b, a minus 1i, plus b, a plus 1i. Again, this could be a complete dead end, but I think I can do it. And let me just do the bottom for you. You get a squared plus 2a plus 1 plus b squared. All right? Wow, that's a lot of work, huh? That's the bottom. I got to do the top now. All right, so the bottom, a squared plus 2a plus 1 . I'm going to bend the chip on this. And I'll tell you why. I'm just thinking that I got something easier to do. And this happens to me sometimes. I'm doing something saying, you know what, why would I have done that? Let me just write this down for you. And I'm going to try something different. Now, granted, erasing the work might have been a disaster, but I'll put this down for you. And I'm going to clear the fraction out. All right? And you're going to get the modulus, a plus bi minus 1 less than 2 times the modulus of a plus bi plus 1. Kind of cleared the fraction for you, all right? Let's do this now, and I'm going to write it down for you. And I'm just going to put this down, square root, and 2 square root, and you're going to get, the first guy's going to be, let's see, a minus 1 squared plus b squared, just doing the modulus now, the absolute value. And on the other side, we're going to get a plus 1 squared plus b squared. Let me see if I did that right. I think so. I'm going to square both sides. Don't panic yet. I'm going to simplify both sides. And what do you get over here? 4 a squared plus 2a plus 1 plus b squared. And what do you get here? A squared minus 2a plus b squared plus 1. Over here you get 4a squared plus 8a plus 4b squared plus 4. Wow, we got some work to do, don't we? So what are you going to get over here? And I hope I didn't make any mistakes here. Let's see, 3a squared and then what do you get? Well, you get 10a, and you're going to get 3b squared. I got to be real careful because otherwise numbers might get really tough, right? So 3a squared, I did that. 10a, I did that. And 3b squared, I did that. And I'm going to get the constant on the other side, minus 3. Oh, boy. Let's see what we got over here. It sure does look like it's going to be a circle, doesn't it? All right, so let's write this down. Minus 3, 3a squared plus 10a plus 3b squared, right? I'm going to divide both sides by 3 just to get that to the nice circle form. So minus 1 a squared plus 10/3 of an a plus b squared. I'm going to complete the square, and that's going to be a squared plus 10/3 of an a. Well, half of 10/3 is 5/3, and when you square that, you would get plus 25/9. I need to add that to both sides now. And then plus b squared. I think I can do this. And that's going to be 25 minus 9, which is going to be 16/9. A squared plus 10a plus 25/9 is going to be a perfect square. That's why I complete the square. Plus 5/9 squared plus b squared. Okay, I think I have it. All right, now suppose, what do you mean you have it? Well, I'm going to put it in a complex plane where this is the a and this is the b. And this will be a circle. Its radius of the circle, radius, would be 4/3, and the center would be minus 5/9, comma 0. Let's take a look at that. I'm going to put that down over here. Minus 5/9, that's the center. And then a radius of 4/3, which should be 12/9. All right, so I'm going to say something like this over here. Oh, they're dashed. I'm sorry. Let me go backwards. Not a very good thing. All right, I know I did that. So I'm going to say, circle centered there. It's all the points on the inside. All points on the inside. So, yeah, maybe I should do a better picture. That's a really crappy looking picture there. Let me get my eraser out. I'll put this over here. I'll write down real. And over here, write down imaginary. And the center, I said, was minus 5/9, right? And I'll put that there. And then the radius is going to be 4/3, which is 12/9. So maybe something like this over here. And it's all the points on the inside. All right? I didn't do a great job drawing that, did I? Let's take a look at the answer key. Let's take a look. It's a long answer key, isn't it? And let's see what they got over there. Radius 4/3, and the center minus 5/3. And let's take a look at the picture. Oh, I think I made a mistake in graphing it. Why did I make it? Oh, you know what? Now I realize what I did wrong. Minus 5/3, 0. Did I put that down? Again, I'm not going to try to blow it off. Yeah, I did. And I don't know where that came from. And I have to look at my work now. But I definitely made a mistake, and I see it now. And the mistake is, I'm not going to say it's egregious, but it's a mistake. And whether it's egregious or not, it's still a mistake. This is a mistake over here. It's not 5/9. What's it going to be? It's 5/3. Sorry about that. I should have checked that. The product should be 25/9. So let's go back to my picture, and I'll put this down over here. So the center is minus 5/3, comma 0. So let me do that. Minus 5/3, and the radius is 4/3. So that's minus 5/3. 4/3 is over here somewhere. All right, and all the points on the inside. Okay, sorry about that. I make mistakes sometimes. The bottom line is everyone makes mistakes. You want to correct them. All right, and I'm seeing that better. 5/3, and I got that. Let's see if I did that. Yeah, minus 5/3, 4/3, which is the radius. We're doing okay. All right, there's one last question. And the last question, I'll be honest, I saved that one because it's kind of an annoying problem. And it requires some thought. All right, it's this trigonometry problem. So what I want to do is I want to erase my work over here. Remember, we started one way and we stopped. We said, oh, it's getting too complicated. And that's when I rethought and I did something different. And you want to do that when you're doing a problem. So what I'm going to do over here, I want to emphasize that I really can't do great pictures of trigonometric functions, but I can start talking about, what they're giving me over here. And I want to make sure you understand what I mean by that. When I'm reading a problem, I need to start visualizing what they're asking for. So I'm looking at it, says, how many solutions are there for this equation over here? Well, hopefully when your teacher taught you this, they said, try to visualize the solution first for something like this anyway. So really what I'm visualizing is 100 times the sine of x is equal to x. So I'm actually visualizing two functions. One of the functions I'm visualizing is f of x is equal to 100 times the sine of x. And the other thing I'm visualizing, another function, g of x, I'm visualizing the function x. Now certainly both functions are not bad to visualize, but how many times do they intersect each other? So what I'm going to do over here is I want to point out that I do have some troubles over here. I know the amplitude of this is 100. So this thing's going to be topping out at 100, and it's going to bottom out at minus 100. I know that much. Now, what do I know about this? I know this line over here is, and again, I'm not saying my scale's perfect, but I know it looks like this, and once it gets over here, it's going to hit a point over here, and that point is when it's going to exceed. And when does that occur? It occurs at the number 100. And by the way, over here, same deal. It's going to hit this line, and it's going to go below that line at minus 100. So now my next problem is visualizing what this looks like. So then the question becomes is, I know the cycle length of this, right? So the cycle length of this, right, is the cycle length of sine is 2 pi. So what do I know? I know this graph goes up, it hits it, it comes back down, whoops, it hits it, and it goes back up. And on one of the cycles, right, on one of the cycles, I'm sorry, my graph looks really crappy, doesn't it? Let me erase this over here. On one of the cycles, this cycle ends over here, it hits it twice, there and there. And then the next cycle ends over here. What does it hit it? Twice again. So I know in every cycle it hits it twice. Every cycle it hits it twice. I'm just looking out to the right of the origin. I'm including the origin over here. And then the question is, how many cycles would I get between 0 and 100? Well, I'm going to say there's going to be n cycles. And I'm going to say, roughly speaking, I'll get to 100 roughly when n is 16. So how many times would it get in those cycles? It would hit 32 times. All right, now I didn't draw it all out. It might be a crappy looking picture, but I know it hits 32 times. Here's the deal though. I'm going to see the same behavior over here. But if I put down 32 again, what am I counting twice? The origin. So it's going to be 2 times 32 minus 1, because I don't want to count the origin twice. This is going to be 64 minus 1, which is 63 times. Let's look. And this is the last one. This is number 3. Let's see what they did. Number 3. You should know it's only possible intersection will occur between minus 100 and 100. Yeah, we talked about that. Each cycle sign is 2 pi long. We talked about that. And we talked it's roughly going to be 16 cycles. A rough graph is shown to you. By the way, not that I want you to go through this, but I think you probably could start counting up. If you had a nice looking graph, you could count them up, right? And you may want to do that for you. To me, it makes me dizzy to count like that. But you could count. So a rough sketch is provided. Noticing symmetry. I did notice the symmetry before. Should be helpful. And there's going to be 63 points of intersection. Did I write that down? Let's make sure it's written down for you. 63 times. We did okay. Thank you for paying attention. I want to point out, don't be discouraged, all right? What I mean by that, if you're doing these problems and you're not looking at the answer key and you can't get them, don't worry. I mean, no one's expecting you to get every single question right. What are they expecting? That you're trying. That's what the expectation is. And if you're trying, you're winning the game. You really are winning the game if you're trying. If you're not trying, though, you're not in the game. But if you're trying, you're winning the game, right? Now, are some people faster than others? Of course they are. Do some people know more than others? Of course they do, all right? There's all kinds of tricks people have up their sleeves, but the bottom line is trying is the biggest trick you could ever have. Thank you for paying attention.